So today is the 18th day of the LeetCode 30-day challenge, and this problem will be minimum path sum. So we are given a m times n grid filled with non-negative numbers. Find the path from top left to bottom right, which minimizes the sum of all numbers along its path. So in the given example, in the problem, given this grid, the best solution will be 1, 3, 1, and 1, 1. Okay? So this is a very famous dynamic programming problem. But before we dive into directly write on the direct code of the dynamic programming, I first want to show that why can we use DP to solve it? Okay, why can we use dynamic programming to solve it? Actually, the idea is very simple, because when we use dynamic programming, we want to focus in first the subproblem has an overlapping structure, and the overlapping structure have the optimal solution. So we take all the optimal solution from all overlapping structure, then we will get the optimal solution for the problem 1. And 3, we have pre-calculate answers, or say we use the answer repeatedly. Because in this problem, in every element of the grid, every element in grid, we can either reach the element from left or from top. So as we can see, this satisfies the subproblem of overlapping substructure, and we will take the mean of 2. So this will definitely comes out an optimal solution. And finally, we calculate the answer repeatedly, because each time we calculate the answer of a given element in the grid, and then when we want the answer from the right of the grid or the down of the grid, we can just use the pre-calculated answer here in the yellow. I use the yellow circle to get the answer for this one at right, or this one at the downside. So now we successfully prove the part 1. And how do we solve it? And the most importantly, I want to solve in constant space, because lots of the solution found in LeetCode discussion forum, usually they build a DP table, and the space complexity will be m times n. So we use the example in the problem 131, 151, and 421. We first initialize the first row or the 0th row and 0th column to be the prefix sum of that. So here 131 will be changed to 145, and then 114 will be changed to 126, and then we're starting to DP at from index 1 to row -1 from index 1 to column -1. So as we mentioned before, each of the element can be reached from either left or top, and then we take the minimum of 2 plus the current element. So at here, the answer will be changed to 7. And at here, minimum of 7 and 5 is 5. So 5 plus 1 is 6. And the minimum of 6 and 7 is 6. 6 plus 2 is 8. And finally, this is the answer we want to return. 6 and 8. Minimum of 6 and 8 is 6. And we take 6. And after we take 6, we have 6 plus 1, which is 7. So return 7 to be the final answer. Okay, that is how we do it. And after that, I will show you how to code in it. Okay, now we are at the coding part. Nothing too special about this code. We first initialize some required variable. And first initialize prefix sum of 0th row. So prefix sum of 0th row will be I think J will be better. Read 0J. Plus the current value. The same is true for the prefix sum for the 0th column. Okay, and then we do dynamic programming. dpij, not dp, sorry, grid ij, which means the cost to reach to grid ij is equal to the mean from top, and top will be grid I minus 1j, and left grid j minus 1 plus grid ij. And finally we return grid row minus 1, column minus 1. Let's see if this works. Great. Okay, thank you for watching and see you in the tomorrow's video.